Dear students, in today's class, we are going to discuss an application of sandwich principle, which is prove that prove that limit of the sequence a raised to the power 1 by n as n approaches to or tends to infinity. This limit comes out to be 1 for every a positive. So we will prove or we will show that the limit of this sequence is 1, and for this one we will make three cases. Case 1, or we'll start with cases. Case 1 is if a is equal to 1, then the sequence a raised to the power 1 by n, this reduces to simply 1 raised to the power 1 by n, and we know that 1 raised to the power 1 by n is always 1. 1 की आप कितनी भी पावर्स कर लो हमेशा 1 ही रहेगा. And limit of this sequence a raised to the power 1 by n tends to infinity, which is nothing but, and this is 1, n tends to infinity, so this is independent of n, so it will be 1. Case second, if a is strictly greater than 1. If a is strictly greater than 1, then let this a raised to the power 1 by n is equal to 1 plus h, where h is greater than 0. We can assume this one because a is greater than 1. A, suppose 1 is here, then according to our supposition a is greater than 1, so a will be here on the right hand side of 1. So clearly this this a is greater than 1, then this a raised to the power 1 by n is also greater than 1, right? If a is greater than 1, then a raised to the power this 1 by n is also greater than 1, so this a raised to the power 1 by n, this power, this lies on the right hand side of 1, right? So this is greater than 1. It means that कुछ ना कुछ हमें इसमें कुछ ऐड करना पड़ेगा, some positive number, because it is greater than 1. Or you can take this. It means that this is nothing but, because it is greater than 1, so 1 plus some positive number h. That's what we have written here. Let a raised to the power 1 by n is nothing but 1 plus h, where h will be some. जैसे आप देख लो 2 is greater than 1, or you can say 1.5 is greater than 1. So we can write 1.5 as 1 plus some number, and that some number is 0.5. इसी को हमने h माना है. So this will be our h, and which is greater than 0. ठीक है. this implies now this will be 1 by n into n, दोनों तरफ n पावर रेज कर दो। तो हमने दोनों तरफ n पावर रेज कर दी दोनों क्वांटिटीज की। कर सकते हैं हम ऐसे, इफ a इज इक्वल टू b देन an इज इक्वल टू bn फॉर एवरी n। ठीक है, तो दोनों तरफ हमने n की पावर को रेज कर दिया दोनों तरफ, तो ये n से n पावर कैंसिल हो जाएगी। सो वी विल बी लेफ्ट विद ओनली a इज इक्वल टू 1 plus h whole raised to the power n, and we know that this is kind of x plus y whole raised to the power n, and हमें पता है binomial expansion, so we will expand this expansion using binomial expansion nc0 1 nc0 1 raised to the power n into h0 plus बाइनोमियल एक्सपेंशन, इसको आपने पढ़ा होगा 10th क्लास में, इनफैक्ट 11th क्लास में पढ़ा होगा बाइनोमियल एक्सपेंशन nc1 1 raised to the power n minus 1 into h raised to the power 1 plus and so on up till ncn 1 raised to the power 0 and h raised to the power n. So this gives us so a is equal to nc0 is 1, so the first term will be 1 plus the second term will be n times h and so on up till h raised to the power n. So obviously this expansion will be greater than or equal to 1 plus n times h, right? ठीक है, होगा ये एक्सप्रेशन इससे बड़ा। भाई ये हमारे पास n टर्म्स हैं, n टर्म्स का सम है और सारी सारी पॉजिटिव टर्म्स है, n इज पॉजिटिव h इज पॉजिटिव एंड a इज इक्वल टू द सम ऑफ दिस n टर्म्स। तो ये सम ऑफ n टर्म्स जो होगी इन दोनों टर्म्स के सम से ग्रेटर होंगी या फिर इक्वल होंगी। दिस सम इज ऑलवेज ग्रेटर देन इक्वल टू 1 plus nh। So this implies a is greater than equal to 1 plus n times h, and this is also greater than strictly greater than nh, है ना। ये जो टर्म होगी 1 plus nh ये nh से बड़ी होगी, तो eventually we will have a is greater than equal to n times h. So this implies nh is strictly less than equal to a, so h will be less than equal to a by, or you can take this as this is greater than equal to, this is strictly greater than nh, this is less than, and this is a by n, and we know that 0 h is greater than 0, h is positive number, and this is a by n, h is strictly less than a by n. So ये एक सीक्वेंस आ गया हमारे पास, ठीक है। इसको मान लो आप bn, let bn is 0 for every n in n, and cn is your a by n for every n in a natural number. So this cn tends to 0 as n approaches to infinity, right? So limit of cn is 0, and this bn also tends to 0 as n approaches to infinity, and this take an to be h for every n in a natural number. So using sandwich principle, which says if we have a sequence an which satisfies this relation, and if bn and cn both tend to some limit L as n approaches to infinity, then this condition forces this sequence an to tend to a number L as, ठीक है। अगर हमारे पास तीन सीक्वेंसेस है जो इस सीक्वेंसेस ऑफ रियल नंबर्स जो इस रिलेशन को अगर सेटिस्फाई कर रहे हो सच दैट बी एन इज लेस देन इक्वल टू ए एन एंड ए एन इज लेस देन इक्वल टू सी एन, एंड बी एन एंड सी एन अगर दोनों एक सेम नंबर पे टेंड कर रहे हो एल नंबर पे, एल रियल नंबर पे एज एन अप्रोचेस टू इन्फिनिटी, देन ये जो बीच वाला सीक्वेंस होगा, ठीक है, तो ये बीच वाला सीक्वेंस ए एन जो होगा ये भी उसी सेम नंबर एल पे टेंड करेगा। अब यहाँ पे देखो ये सीक्वेंस बी एन दिस टेंड्स टू जीरो एज एन अप्रोचेस टू इन्फिनिटी, this also tends to zero as n approaches to infinity. It implies that by sandwich principle this sequence an will also tend to zero as n approaches to infinity. तो इसका मतलब क्या हुआ, limit of an is zero as n tends to infinity, and an क्या है हमारे पास यहाँ पे, an is your h n tends to infinity, ठीक है। now an क्या था हमारे पास, दिस इज इक्वल टू 1 प्लस एच, लिमिट ले लो, दिस इज नथिंग बट ए रेज टू पावर 1 बाई एन, इसको हम ऐसे ले सकते हैं, तो लिमिट ले लो दोनों तरफ, लिमिट ए रेज टू पावर 1 बाई एन n tends to infinity, this is limit of this sum 1 plus h. So using the algebra of convergent subsequences, this is limit of 1, so 1 plus limit of h n tends to infinity, and this ये limit क्या आ रही है हमारी 0, so 1 plus 0 is 1, ठीक है। So there is another application, prove that limit n raised to the power 1 by n, this limit comes out to be 1 when n approaches to infinity, ठीक है। now we will proceed to case third. Case third is if a number a lies between 0 and 1, then we need to check that limit of a raised to power 1 by n, this is also 1 as n approaches to infinity, ये केस हमारा भी रह रहा है। so इस केस के लिए हम क्या करेंगे, a is less than 1, 1 by a will be greater than 1 obvious, so take b to be this 1 by a, take b to be this 1 by a, so by case 2 की हेल्प से 1 by a की पावर 1 upon n, this also tends to 1 as n approaches to infinity. Case 2 says if a is greater than 1, then a raised to the power 1 by n tends to 1. so यहाँ पे हमने case 2 की हेल्प ली है, with the help of case 2 this b is strictly greater than 1, so b raised to, or you can say this b raised to power 1 by n, this tends to 1 as n tends to infinity, right? so therefore limit of 1 by a raised to power 1 by n, this limit is 1 and tends to infinity. so using the algebra of convergent sequences हम लिमिट को ऊपर नीचे डिस्ट्रीब्यूट कर सकते हैं, so limit of 1 is 1, so 1 by और नीचे by limit of a raised to power 1 by n, ठीक है, using the algebra of convergent sequences, so इस लिमिट को इस तरफ ले जाओ, So we will have limit of a raised to power 1 by n as n approaches to infinity, this is 1. So हमने सारे केसेस कवर कर लिए. केस 1, a क्या था? a was any positive real number. a was any positive real number. तो सारे हमने केसेस कवर कर लिए. पहला क्या था हमारे पास? if a is equal to 1, this is 0. पहला केस हमने क्या किया? if a is equal to 1. सेकेंड केस में हमने क्या किया? if a is greater than 1, so this is a is greater than 1. तो यहाँ पे सारे नंबर्स कवर हो गए greater than 1 वाले. और लास्ट केस में हमने किया if a lies between 1 and 0. तो इस केस में भी लिमिट हमारी क्या आ रही है? लिमिट ऑफ a raised to the power 1 by n, that is also 1. So all cases have been covered in these three cases. So hence we can say that, or we are in a position, hence limit of a raised to power 1 by n as n goes to infinity, this limit is always 1 for every a greater than 0. So this is a beautiful application of sandwich principle.